this is King of Review. Here we have to find the value of x that solves this equation so that we can then find the value of 10x. So in this equation, let's start by trying to deal with this square root inside the first log. Square roots can be written as exponents by treating the exponent as 1/2. That means the same thing as the square root of 3x plus 1. Now, it would be nice if we could do something with that 1/2, and we can. There's a nice property of logs with exponents that says if you have the log base b of x to the power a, that's the same thing as a times the log base b of x. We take the exponent and move it to the front. Let's do that with this exponent so that we don't have to deal with it inside the log anymore. So we have 1/2 times the log base 2 of 3x plus 1 equals 1 minus 1/2 log base 2 of 2x minus 1. Since we're trying to solve for x, let's put all the x's on the same side, so let's move this log, 1/2 times log base 2 of 2x minus 1, to the other side of the equation by adding it on both sides. So now we have 1/2 times the log base 2 of 3x plus 1 plus 1/2 times the log base 2 of 2x minus 1 equals 1. Let's get rid of these 1/2 so that we just have logs on the left side. By multiplying the entire equation by 2, the 1/2s go away, and 1 turns into 2 on the right side. Now, since we have two logs with the same base being added together on the left side, we can use a nice property of logs that says if we have the log base b of x plus the log base b of y, that's equal to the log base b of the product x times y. Using that principle on the left side of our equation, we get the log base 2 of 3x plus 1 times 2x minus 1 equals 2. Now, if I want to get rid of the log, I can use one final property of logs that says if you take a number b, raise it to the power log base b of x, the b and log base b cancel, and we're left with x. I would like to raise 2 to the power of both sides, since 2 is the base of my log. 2 and log base 2 cancel, and I'd like to distribute these two parentheses together to expand them. So I get 6x squared minus 3x plus 2x, which gives me minus x together, minus 1. On the right side of the equation, we have 2 squared, which is 4. Since this equation has x squared as its highest exponent, I'd like to set it equal to 0 to solve. So I need to subtract 4 on both sides, and I get 6x squared minus x minus 5 equals 0. Now, quadratic equations can often be factored. That's generally the easiest way to solve them. And with a little bit of guess and check, we can figure out that this equation factors into 6x plus 5 times x minus 1. Distributing these back out will give us 6x squared minus x minus 5. So this means that either 6x plus 5 equals 0 or x minus 1 equals 0. One of these two factors has to equal 0. If we solve this first equation, we get x equals negative 5/6. If we solve the second, we get x equals 1. But I'm not sure both of these will work, because there's something else we know about logs. Logs can't take any number less than 0. So for example, if we take 2x minus 1, the value inside our second log, 2x minus 1 has to be greater than 0. If I solve this equation, I get that x has to be greater than 1/2. So now I know that negative 5/6 will not work because that's not greater than 1/2. Now let's check the other log. If x is bigger than 1/2, I multiply it by 3 and add 1, it will definitely be greater than 0. So if x is greater than 1/2, both numbers inside my two logs will be greater than 0. So x equals 1 is my actual answer for x. All I have to do now is find the value of 10x. 10x will be 10 times 1, which is 10. And there's your answer. Thanks for watching.